Let's do another example where we sketch a transformation of a tangent function. We'll follow the same outline as we did previously. So first, we'll identify what the parent function is. Of course, the parent function is tangent of t. And so if you write that f of t is tangent of t, then this here is equal to 1/2 f of 2t minus pi over 4. And remember, whenever dealing with transformations, you want to make sure that you factor out whatever is on the t. So 1/2 f of 2t minus pi over, and let's perhaps give myself a bit more room, t minus pi, and 2 times what would be pi over 4? Well, if you don't see the answer immediately, write out what it is. So I suppose if I did not see the answer immediately, I would write a question mark there, and I'd say 2 times what is pi over 4, and then you can divide both sides by 2 and you find that, well, that should be pi over 8. And so this is equal to pi over 8. So that will set up our identifying the horizontal transformations later. Let's start out with identifying the midline and the upper and lower line. So the midline, that's going to be the transformation of y equals 0. That is the vertical transformations of y equals 0. So I suppose I should list what the vertical transformations are before I do this. All we have in this problem is a vertical shrink by a factor of 1/2. And so the midline is the old midline, which was y equals 0, and we'll multiply by 1/2, and of course that gives us 0. We'll get the upper and lower lines too. So we're going to take 1 and -1, and we'll simply multiply them by 1/2. And so we get positive 1/2 and negative 1/2. Now let's work on those important t coordinates. So we'll take our asymptotes first. So minus pi over 2, and again, it looks like I neglected to list out the horizontal transformation, so let's do that. We have a vertical shrink by a factor of 1/2 due to that 2, and we have a right shift by 8. And I think I said vertical shrink. If I did, I meant horizontal. So horizontal shrink by a factor of 1/2. And then we have a right shift by pi over 8. So let's take our first and fifth important t values, which correspond to the asymptotes. From the parent, we have minus pi over 2. And we'll go ahead and multiply this by 1/2 and shift it right by pi over 8. And so we get minus pi over 4 plus pi over 8. And that will end up being minus pi over 8, getting a common denominator and adding these together. Finding the fifth important point, we have pi over 2 times 1/2 plus pi over 8. So this is pi over 4 plus pi over 8, and that's 3 pi over 8. Again, multiplying this first term by 2 over 2. I think I want to fill in what we have so far on a graph. So for the y scaling, I think I'll pick, let's see, I want to give myself enough room, so I think I'm going to pick this to be 1 and this to be 1/2, and thus this would be negative 1/2. And on second thought, I think that doesn't leave me very much room down here, so I think I'll pick my scaling to be so that this is 1, and so minus 1/2 is here. I think that will give me enough room. Or plus 1/2 is here, and minus 1/2 is down here. And usually we don't label the 1/2s, we just label the 1. And so my midline is y equals 0, so we have the t-axis as the midline here. Let's see if I can't get a straight line going. And then my upper and lower lines are positive half and negative a half. Then for my horizontal scaling, I think I'll pick this to be pi over 8. That way this is minus pi over 8. And then 2 pi over 8, 3 pi over 8. And I don't have a lot of room to label, so I'm just going to note that this here is pi over 8. This is 3 pi over 8. And this is minus pi over 8. Of course, this is 0. And this point here would be 2 pi over 8 or pi over 4. I'm going to go ahead and erase this though because I'm going to need some space. By the way, this is one of those examples where it's not too difficult once you figure out the asymptotes what the third, second, and fourth points are, because these two here are the asymptotes. So we'll go ahead and draw our vertical line at the asymptotes like this. And then halfway between pi over 8 and 3 pi over 8, you can visually see is pi over 8. Halfway between pi over 8 and minus pi over 8 is 0. And halfway between pi over 8 and 3 pi over 8 is pi over 2. Or excuse me, pi over 4. But I'll go ahead and run through the calculations. So for this third point, I don't need the dashed line anymore. We would have negative pi over 8 plus 3 pi over 8 divided by 2. That's 2 pi over 8 in the numerator, which is pi over 4. And pi over 4 divided by 2 is pi over 8. Then our second coordinate is halfway between the first and third. So negative pi over 8 plus pi over 8 divided by 2. That's 0 over 2, which is just 0. And the fourth coordinate is halfway between the third and fifth. So pi over 8 plus 3 pi over 8 all divided by 2. Pi over 8 plus 3 pi over 8, that's 4 pi over 8. And 4 pi over 8 is pi over 2. So this is pi over 2 divided by 2, or in other words, pi over 4. Now we can go back to our graph, and let's remember what we're sketching. We're sketching 1/2 tan 2t minus pi over 8. So 1/2 tan 2t minus pi over 8. And we already have our important t coordinates marked because, as I mentioned before, you can sometimes find them just by inspection. And so now I'll go ahead and note that there's no reflection here, so we're not going to start at the top line here. We're going to start at the bottom, and we'll fill in our points at the bottom line, midline, then upper line, and then we'll draw in the shape of our tangent curve. So it will look something like this. Finally, this is not such a big deal, but usually when one draws tangent curves, you don't keep these horizontal lines here. It's very frequent or very common to keep the horizontal lines there in the context of sine and cosine, but in the context of tangent, it's not common to see those horizontal lines. So maybe I should do that for this other one as well. Oh, that erased the whole of the t-axis there. Let's see if I cannot just erase part of it here. Okay, there we go. Finally, let's go ahead and list the important characteristics about this graph as we've discussed in the previous graph. So the stretching factor, that's the vertical stretch without the negative, so that's 1/2. The midline is the vertical shift, and the vertical shift here is just 0. The period is pi, the period of the parent, divided by whatever is here, so 2. And then finally, the phase shift is positive pi over 8.